When it comes to working with applications of radical equations, you have to remember that the world does not typically work out so that the answers are nice, neat, and orderly. A lot of the time when you work with a radical equation application, like the one you see here, you are not and you should not anticipate a nice and neat answer. You should expect there to be some estimating, some potential rounding, because you're talking about a lot of messy operations with numbers that occur in nature as opposed to problems that are designed by a math teacher to work out very nicely. So this is a situation where it's difficult to come up with examples to practice those skills that we want to establish in this lesson. But it's worth taking a look at an application just so you can see how this problem-solving process might apply. So for this particular example, they do give us that the sustained wind velocity is 54.5 meters per second. That being said, we can substitute 54.5 into the equation, and it's going to look like this. Now, if you're thinking through our problem-solving process that we've already established, let's go ahead and do this division. Even though we've had some examples where we left that number there in front of the radical before we did the squaring, we know that we're going to have to do some kind of estimating here. So there really isn't much concern with the fact that the rounding is going to happen pretty early on. 54.5 divided by 6.3 comes out to be approximately 8.65, leaving that equal to the radical. Then we square both sides as we normally would in an effort to get rid of that radical. So we'll square left and right. And we're up to 74.8 is approximately 1013 minus p. Solving the rest of that equation by subtracting, maybe dividing by 1 as necessary, you get that p is equal to 938.2 millibars, which is how the unit of measurement for air pressure in this example. Again, I just wanted you to see that there are examples out there that you can use these functions for. If you think of the square root function, you're thinking of something that grows, but the growth sort of tapers off towards the end. It slows down. It's not growing as fast as it was previously. So just take your time. There's going to be some rounding. There's going to be some calculator work. Maybe Desmos to check your answer on these kinds of examples is of value because you want to make sure that you're interpreting them correctly. And at the same time, these calculations can get kind of messy. So you want to make sure you're being responsible and checking your work.